2.4 inverse functions. We'll discuss first just an idea about inverse and then we'll go to inverse functions. Um, Assume cars, and I will write here cars have power mirrors, power shutters, leather seats, GPS, and some other options. So power mirror, power shutter, leather seat, GPS. So so if a car has power mirror and power shutter and this all extra things, we can say this is super luxury. And some of this one, then luxury. And then standard, few missings, than this standard. Then we can say economical or any other. So it is depend on the facility of the car. We can categorize super luxury, standard, or economic. So likewise, we can categorize number systems. If it is follow closure law, associative law, zero law, or identity. And inverse law. So commutative law. Likewise, power mirror, power shutter. So if a number systems have those options, so we will categorize everything with a field, then group, ring, subring, something like that. So we can categorize these number systems. So this identity, zero law or identity, and the inverse is a part of this. So we can assess a number system. For example, what are the number systems? We have um, natural numbers, one, two, three, four, five. Then whole numbers, and then integers, whole numbers 0, 1, 2, 3, 4, 5, integers minus 3, minus 2, minus infinity to 0, 1, 2, 3, infinity. Then real numbers, irrational and irrational separately, then the real numbers, and then complex, um, what else? So likewise, I'm going to take identity and inverse law. I'm going to discuss on this one for your understanding bit. So I will consider what is identity. Identity is if you consider a pot in the sense the numbers, okay, integers. So minus infinity to plus infinity, all the numbers there, minus 3, minus 2, 0, 1, 2, 3, like that. So identity means under any operations, what are the operations? Let's say plus and multiplication. So I'll consider plus. So we have to check these identities on an operation. So it can be plus or multiplication. So I'll consider first of all plus. Under plus, when I consider integers, identity mean if you select any number, which number you want to select, 100, and operation is add. When you add to any number here, when you add any number to 100, you will get the 100. You should get the 100. And assume another number, 99 or minus 5. Then when you add a number, you will get again minus 5. So if there is such number exist, then it has a identity. Is there any number exist? Yeah, because 0 is there. If 0 is not there, it's not identity. There's no identity. So when you add 0, still you will get this number. So then it has a one good quality in this number system, because there is a one element, that element when you add to another element, the number is going to be the same. So then it has a identity. Or it's comply with 0 law. Now what is inverse? Inverse mean under addition, you should get 0. If you select any element, so I will take 2, and when you add to another element, you should get the identity. Now you have 2 here. To get 0, to get the identity, so here ID is 0, so get the ID, what you should have? You should have minus 2 here. Is minus 2 in this spot? Yes, minus 2 is in this spot. Hence, it has a inverse. So 2 has a inverse, that is minus 2 under multiplication. Now we'll consider under this operation with the same pot. Integers minus 3, minus 2, 1, 0, 1, 2, 3, dot, dot. When you take any element here, I will take 88. And when you multiply, is there any number that you will get 88 under this operation? Yes. Okay. I'll consider another number, minus 7, and multiply by another number, you will get minus 7. Is there any such a number in this spot? Yes, there is a number. That number in this spot, if not, it is not complying. So yes, there is a number 1. When you multiply by number 1, you will get the same. Hence, under multiplication, now ID is 1. Now, under multiplication, what is the inverse? Let's consider any number, 76. And when you multiply, because that is the operation, we should get the identity. What is the identity of this system? 1 under multiplication. Under addition, to get 1, what do you have? What do you need? 1 over 76. So now is 1 over 76 is in this spot. 1 over 76 1 over 76 not in this spot. 1 over 76 is not an integer. So then under multiplication for integer there is no inverse. So now integers is not like super luxury. Because under addition it has ID and it has inverse. If you select any number from this spot, yes, the inverse also there. But under multiplication, yes, ID is there, but there is no inverse, because to get ID there should be for any number. Assume if you select 7, then you need 1 over 7 to make 1, but 1 over 7 is not in this spot. It is not an integer. So in that case, under multiplication, there is no inverse. So accordingly, it's not super luxury, or we will categorize as not field is the best one. So this is the idea behind the inverse. One more example. Now we talk about this is integers. How about under natural numbers or counting numbers? Usually it's depend on 1, 2, 3, 4, 5. Right. So if I consider there is no 0, then this is under addition it is fail, this one, because there is no ID. If you consider 100, yes, 100 in this one, in this spot, but to get to 100 under addition, is there any number? No, there is no 0 here. So there is no ID. When there is no ID, there is no inverse under that operation. How about the multiplication? Multiplication also, okay. Is 88 is a element of this one? Yes, 88 is a natural number. And can I get 88 by using this operation? Is there any number? Yes, 1. If you select 7, then we can get 7 multiplying by, so 1 over 1 is ID. So we under multiplication, under addition there is no ID. But under multiplication there is an ID. How about the inverse now? So we pick up 3. And when you multiply by, now we know that ID is 1. 1 is here. Any number here to get 1. Any number here when you multiply to get to 1. So we need 1/3. So one third is not a natural number. So then it is, there is no inverse. There is no inverse basically for all the numbers. So it is failing again. So we should have a number system and we should have operation, and then if we have a ID then we can check the inverse is there. But now I'm not going to merge this one into function, but I will start straight from there. So what operations functions have? You can add functions, multiply, and composite function of function, and we define function, inverse of function basically, f fx, and its inverse function f inverse x. So f inverse x, and f inverse x, f inverse fx should be x. So we'll discuss now what is this one first of all. So I have a function fx, 2x minus 1 divided by 4. I'll take two element in domain x equal to, and x equal 4, only two element. So those are the domain 2 and 4. Then what is the range is going to be? When you put 2 times 2, 4 minus 1 over 4, 4 minus 1, 3 over 4, 3 over 4. When you put 4, 2 times 4, 8 minus 1, 4, this is 7 over 4. Now this is the function. Now can you find another function? Let's say gx. When you put 3 over 4, you want to get 2. When you put 7 over 4, you should get 4. We'll consider that as gx. So how do you find that? So when you put 3 over 4, you should get 2. The other way around. So now for gx, what are the domain? 3 over 4 and 7 over 4. What is the expected range? 2 and 4. So this is the function the other way around. Now from when you put 7 over 4 to get 4. For example, when you put banana and apple, you will get smoothie, banana and apple smoothie. So I am asking another machine type. When I put a smoothie, banana and apple smoothie, I need banana separately and apple separately. So if this is fx, and let's say this is gx. So gx is going to be the inverse of x. So what is the inverse function of this one now? Reverse operation. When you put 7 over 4, you want to get. So how do we do this one now? First of all, if I have 7 over 4, okay, let's say 3 over 4, I can see if I multiply by 3 over 4, I want to multiply by 4. Then I will make 3. Then this value, I want to add 1. because minus, then I will add 1, 4. Then to get x, this is multiply, then I want to divide by 2, which is 2. So basically I want to get this value, let's say alpha, then I want to multiply by 4, then add 1, and then divide by 2. This alpha symbol is not clear, so I will put beta or capital M, something like that. That's wrong. So M time, whatever it is, multiply by 4, add 2. So when you put 3 over 4, multiply by 4 become 3, add 1 and divide by 2. So 7 over 4, shall we check whether it is working to 7 over 4? 7 over 4 multiply by 4, add 1, divide by 2. So 4 to 4 cancel out. 7 plus 1, 8. 8 divided by 4. Yes, we will get 4. So that is the function. So basically, this is the inverse function. So if I write as a function, the inverse function x m times 4. So now I am going to write x times 4 means 4x. Then add 1 and divide by 4. So now by looking at, I found out what is the inverse function of this. So domain is, what is the inverse function of domain? 3 over 4, 7 over 4 for this one. Now we'll follow whether this one follow the definition. If x to become an inverse, if inverse x, and then f inverse fx equal x. So this is the composite operation. You know what is composite now. First of all, f inverse x. So I'll write, we need to find, I'll write fx first. 2x minus 1 divided by 4. Then I want to substitute here f inverse x. Then here also f inverse x minus 1 over 4. So what is f inverse x now? We know that 2 times 4x plus 1 over 2 minus 1 over 4. So 2 to 2 cancel out. Then 4x plus 1 minus 1 over 4 mine to cancel out. Then 4x over 4, 4 to 4 cancel out x. So this is okay now. F inverse, fine. Now we'll work the other way around. F inverse fx, we will get x. So first of all, I write f inverse x. 4x plus 1 over 2. Then I sub this one into fx. 4fx plus 1 over 2. 4 times fx means 2x minus 1 over 4 minus 1, no, plus 1, plus 1, and over 2. Now this 4 to 4 cancel out. 2x minus 1 plus 1 over 2. This is the minus 1 to plus 1 cancel out. 2x over 2, which is x. Right. This is also right. So then fx is the f inverse x. This one is the, okay, whatever it is, this one is the inverse of this one, fx. Now we'll find mechanically, how do you find this one? So this is the inverse this is the function given. I want to find f inverse x. How can I find this one now? The simple method is just make x as a subject. So I'll multiply by 4 times fx, 2x minus 1. Then 4fx, I'll bring minus 1 to plus 1, 2x. Then I divide by both sides 2. 4x plus 1 divided by 2. This is x. When you bring to like this, what you need to do, so this x going to be f inverse x, and fx you just put x. Or instead of fx I write y equal to x minus 1 over 4. Bit less confusion because this is not fx, y, it is easy. So then cross multiply 4y equal to x minus 1. Then I'll bring to this one. Okay. I will write 2x minus 1 equal 4y. A equal b, can I write b equal a? Yes. So I'll put this one left and this one. Then I'll bring to other side 4 plus 1 and I divide by 2. So x equal 4y plus 1 over 2. Now instead of x we put y, instead of y we put x, we change. So instead of x we put y, and when we have a y we put x. So this is the inverse function mechanically you can find. If you consider another example, y equal x over 4 plus 2 fx. What is the inverse function of this one? So I will put y equal x over plus 2. Then I'll make x as a subject. Okay, I will write like this because x is here now. Then I will take 2 to other side, y minus 2. Then x equal cross multiply 4, y minus 2. Then I made x as a subject. Then x to y to x become y, and y become x. This is the inverse function. So if you consider this is fx, we'll write f inverse x. If you get gx, then this is not f inverse x, this is g inverse x. So this g inverse will not 1 over gx. This is a wrong idea. This will imply that inverse function, not the negative power 1. Now fx is 4, and we found out the inverse function is 4x plus 1 over 2. Now 2 and 4, under this one, under function, we will get 3 over 4 and 7 over 4 for this one. Then when you put f inverse x, right, so it will become 2 over 4. Basically, what is this one? This is a domain of fx. Domain of fx. What is this one? This is the range of fx, this one. When you consider this function, when you consider inverse function, so what is the domain for inverse function? So this one is the domain for domain of f inverse x. And for f inverse function, what is this one? range of f inverse x. Now, now you can see that same stuff, but two different names, same stuff, 2 and 4, domain of fx, 2 and 4 we call domain of fx or range of f inverse x. So what you can tell now, domain domain of fx equal to range of f inverse x, and the same as range of fx is equal to domain of f inverse x, both same. And range of f inverse x is domain of fx. So I wrote the same thing, it's not a different thing. So sometimes student may get confused, two different things. Domain of fx is range of f inverse x, and the same thing I can write range of inverse x, domain of fx, but it is not this one. It is the same thing I said uh, differently. Now I have a function. I have a function. Okay, this is my function. So what is the inverse function now? The inverse function is always, so if we have a expression, algebraic expression, equation, so we can write the inverse function. If we have this is y equal x square plus 2, something like that, then we can make x as a subject and we can find what is the inverse. Now just the graph only. Then how do we find the inverse graph of inverse function? So the graph of inverse function we can find if we y equal x line, 45 degrees line from the x-axis. If you bring a mirror and if you keep on here, that's how we usually make mirror. And if you look at the reflection, mirror reflection, so that is the inverse function. So this is the, if this is fx, this is the inverse function of x. Same as if you consider this is fx, this is the inverse function of x, mirror reflection. Assume I want, so this is actually not 45. Assume I want to find this part, the mirror inverse function I want to draw. Then you can draw, basically you want to draw the perpendiculars 90 degrees to this line. And now you can see this distance. So you want to get the same distance here. This distance, same distance here. So here to here, the same distance. Here to here, the same distance. Then here to here, the same distance. And then you can take a curve. So those all are perpendiculars, 90 degrees. Another one, y equal ex. This is y equal x line as a mirror reflection. Then ln x. So this is the This is function, this is the inverse function. This is the function, this is the inverse function. Basically, we should know everybody the function of ex. The inverse function of ex is ln x. So it's going to be like this.